Hello, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. I'll begin in just a moment, but first I need to conduct a little bit of housekeeping. Could you please raise your hand using the hand icon in the GoToWebinar control panel to let me know if you can hear me okay? And let me take a look. Can you hear me? Okay, yeah, looks like everyone can hear me. Next, during the discussion, you will be on mute, but should you have any questions during the discussion, go ahead and enter them in the questions field within the GoToWebinar control panel. And at the end of the presentation, we'll take time to answer as many questions as possible. And those that aren't answered will be addressed in a follow-up blog post on the GridGain Systems blog. With that said, I'd like to thank everyone for attending today's webinar. It's called Accelerate Mobile Apps with In-Memory Computing, and it's being presented today by Director of Technical Marketing, Matt Sorrell. And Matt, go ahead, you have the floor.
Why, thank you, Elisa.
You're very welcome.
Good morning, everyone. Here we are to talk about accelerating mobile apps with in-memory computing. It's kind of funny. Before I start, Elisa and I were just chatting before the webinar started, and we were saying that we talk about accelerating mobile apps, but really we're talking about accelerating the infrastructure that serves up the mobile app. So we're not actually talking about accelerating the mobile app itself. We're talking about accelerating the back end, which will, in effect, it's more like accelerating the mobile app experience, I think, rather than just accelerating the app. So next time we'll have a better title. Let's see, let's go through our agenda quickly. I'm going to give everyone an introduction to the topic and to in-memory computing, and sort of do a high-level overview of GridGain and Apache Ignite, and then go into some survey responses that we had where we asked software developers and mobile app developers how they're using GridGain or Ignite. Then I have 3 or 4, I can't remember, use cases to go through, like, let's see, high-speed transactions. I'm also covering real-time analytics, and I'm also covering building a messaging platform in memory. Okay, and then after that, I will go into a more in-depth explanation of GridGain and Ignite and the features. So here's me. I am Director of Technical Marketing at GridGain. I have about 30 years in technology, which makes me sound old, but I start counting when I wrote and sold my first application, which was when I was in high school. I was a baby. And anyway, I'm kidding. It's just because I feel old working in Silicon Valley at being over 40. And here's my contact information. You can read my email, and I'm on Twitter. I also blog a lot on our blog. And also, if you go to gridgain.com, under resources, we have a lot of white papers as well to explain, like, other topics. You know, the way that we've approached this is like accelerate mobile apps, but then there's also a build faster software, and there's also you know, explanations of how to use in-memory computing for real-time analytics and stuff like that. So let's see. So to give an intro, mobile application development, basically, you know, my point on this slide is that this is really something that's taking off, you know, which I don't think I have to tell you if you're listening to this. There are a billion smartphones out there. So this number kind of blew me away, that about 179 billion mobile apps were downloaded in 2016 alone. That's for both iPhone and Android. Which seems like a lot, but I guess my point here is if we're going to download that many apps, then your app had better be fast and it had better do what it says it's going to do, or it's going to be deleted and someone's going to move on in a second. The leading categories for apps were messaging, navigation, like GPS, social media, readers, games, retail, banking, and travel. Okay, so let's look at some trends affecting mobile application development. Let's see. The first is wearable devices. So according to IDC, 101.9 million wearable devices were shipped in 2016. This is up about 30% from the year before. And it's sort of being driven by this the smart wearable, like the Apple Watch. And this shows a trend from wearables sort of just being like a kind of cool extra to wearables now being part of the mobile ecosystem. And typically you'll have a wearable that communicates with an app that's running on a smartphone. And so this now opens up new opportunities for app developers to write code that uses the smartphone as the hub of a personal area network that's built from a bunch of wearable gadgets. These gadgets can do things like be sensors or be interfaces, provide smart display, augmented reality, things like that. And the gadgets communicate with mobile apps, they deliver information in new ways, so they sort of capture information as well as deliver information. And this is a developing area of mobile application development. So hand in hand with that is IoT, looking at smart devices, smart homes, other devices that connect to phones and can be accessed through a phone or a tablet, that could sort of either act as like a remote control or interface with the devices and share information from the device, analyze the information that the device is presenting, be a gateway to social networks because everyone likes to post what they're experiencing. Another sort of interesting angle on this is that the combination of IoT and mobile devices, they give rise now to location sensing and precise location sensing, which means that you can do a lot of like personalization and customization on the fly. I think that's a pretty cool thing. So like a smart home where you enter the home and now your thermostat's regulated, the lights dim to exactly how you want them, things like that. So I guess in a way, what I'm getting at here is that mobile apps aren't just about this closed experience on a phone. This is continuing to grow and really enter worlds that we hadn't even anticipated a couple of years ago. Looking at other trends, mobile commerce is started. I don't know if I could say, you read the analyst reports and they talk about it starting, but I see mobile commerce everywhere already. But I think maybe it is just starting. We're at the kind of the tip of the iceberg, so to speak. And this is like using your mobile phone to pay as well, in a physical location, and also to shop directly from your phone. And I think an important thing for mobile apps is that mobile commerce gives us not just the commerce, but also a huge amount of data that we can start to analyze and understand about the way people shop and what they're looking for, and so become smarter over time. Ugh. My mouse has this very sensitive wheel, so it's like if I even look at it, it changes my slide. I'm going to stop using my mouse. All right. And again, I sort of hinted at motion and location sensing before. So now the combination of GPS and also like Wi-Fi and RFID pinging gives us the ability to know an individual's location within 10 feet. So we can start giving them like hyper sensitive, hyper specific location specific information, like services and deals. And the other day I was at the mall and I didn't even know there was a Verizon store, but all of a sudden my phone buzzed and started giving me a bunch of Verizon deals should I choose to enter the store, which I personally found a little annoying. But you know, it's a way to make money, so we'll all be writing applications that do this. And I guess motion sensing is also important for security and fraud detection, as well as for gameplay. Okay, also other trends that we're starting to see are changes in, this is more of an evolution in the way that interfaces are designed now. You know, sort of harnessing a small screen or like a card-based interface, you know, making an effective display of the data on a small device that's, and now we're starting to see intuitive designs because we've used these things for more than a few years. So we already have our ideas about how we'd like to work with these devices, and you know, also starting to face, or not starting, but continuing to face challenges and starting to solve them in innovative ways. The challenge of partial user attention and interruption, like only having a minute to do this because I'm on my phone somewhere. And I guess another trend we're starting to see is just better application performance management, visibility into application behavior, because now we can monitor everything from the application to how the application runs on the phone, accesses the network, data traverses the mobile network. We can monitor our infrastructure, and you know, we can really see detailed statistics about device, operating system, carrier, various components of our infrastructure stack, and we can track user behavior as well. So we now have a much better idea of what users are doing and how performance is enabled by various components of the equation. So that is a good segue to go from understanding performance to how do we get to better performance. In-memory computing is driving a revolution in performance and scalability. And we're starting to see the demands that are placed on applications, the like mobile scale and web scale demands that are placed on applications, and at the same time that the technology is available to move data into memory, the price of memory comes down, and so it becomes more compelling to start using in-memory technologies. So here's a little graphic of RAM prices coming down while at the same time data is growing, and the technology is now available to work with this data in memory and get better performance and scalability. Gartner is also huge fans of in-memory computing. They've broken out the market to what it's worth over years, and I guess What's important here is that it's growing, and there are reasons for that. And I think what's important too is understanding that in-memory computing can be a whole bunch of, actually, let's look at this. In-memory computing can mean a whole bunch of different things to different people, right? So it's like, look at, they've got these categories. You could even break these categories out further. So in-memory database, what's in-memory analytics, an in-memory data grid, and then you've got in-memory caching, and then you've got in-memory application servers, in-memory this, in-memory that. And so at GridGain, we talk about providing a complete in-memory computing platform. And this means that we're not just a point solution. We have a whole bunch of things that we do in memory. Basically, we provide a lot of features like caching, compute, parallel processing, in-memory, SQL, streaming data analysis, and there's no need to rip and replace your existing application or persistent store because we have a unified API, and we also speak SQL, so we can just insert our computing platform between your application and your existing database to provide the performance and scalability of an in-memory solution. And because of this architecture that I'm describing, we work with a whole bunch of different platforms, and it's a very, very versatile and open platform. And we can be deployed anywhere, on-premise, in the cloud, in a hybrid environment, wherever you've got commodity servers. So I guess, how do we deliver all these features? We have a data grid, the compute grid, SQL grid. I'm going to go into detail on all of these. This is just a little teaser to tell you what's coming. Service grid, and we also provide Hadoop acceleration for the big data world. And we do this with advanced and automatic clustering. We have an in-memory file system as well as an in-memory database, in-memory messaging, and event processing. And we use we're basically an in-memory key value store. So this is an adaptable data structure. All right, so I talked about sliding the GridGain data grid in between your application and your database, and that's exactly what this slide shows. So you slide, you've got your database and your application, and you need better performance, so you slide us in between, and then you can access your data from, now it's in RAM and distributed across our grid. And so you get the advantages of distributed computing and parallel processing, as well as the advantage of moving to an in-memory architecture. And also with the advanced clustering, we have high availability features so that we're always available and we're scalable as well. And then throw onto it the requirements of providing ANSI SQL 99 capability or compatibility, and also guaranteeing ACID transactions. And there you go. That's my pretty build of a slide. The Apache Ignite project, GridGain is based on Apache Ignite, or Apache Ignite is the open source version of GridGain, depending on how you want to look at it. It's a highly successful open source project. It's also a good way for you to get started, and you could just sort of download Ignite and play with it and learn about these features and capabilities that I'm talking about today. The next thing you might want to wonder is, so if Ignite's good, then what do GridGain and GridGain Professional and GridGain Enterprise get you? Basically, the answer is they get you support, and they get you a lot of other high availability and security features. So the things that you would need to really put a solution into production or use it in an enterprise for in-memory compute. So if we look at what GridGain can be used for in memory, this is sort of a breakout of everything that we can do. And this is like, let's see, if we pick out the ones that would be good for our mobile apps, we might be looking at distributing caching, the scalability, looking at doing high performance computing, like real-time analytics, distributed SQL processing, like all these things that give us power and scalability, because that's what we really need when we start building infrastructure to support mobile applications. GridGain is also deployed all over the place. We've got a lot of our clients are in financial services, doing things like risk analysis and fraud detection. We've got a fair number of people doing high frequency trading. Anything where you require like the speed and scale, ultra low latency processing, things like that. We have a lot of customers in retail and in travel that use GridGain for real-time analytics, like dynamic pricing, customization, things like that. We have quite a few IoT customers because of our real-time streaming processing abilities and complex event processing. And we have quite a few biotech customers as well that are doing like genome matching and drug discovery. So these are like data, where performance and scalability like really matters. That's where we play. All right, so we sent out a survey to a bunch of our users, and we asked them, to a bunch of our developer users, software and mobile app developers, we asked them, why would you use in-memory computing? And the big answers here are database caching, application scaling, high-speed transactions, and real-time streaming. So let's see. Then we asked them, where do you run GridGain and/or Ignite? And our answers were in the private cloud, on-premise, and then AWS, Azure. Thing is, we could run anywhere, right? So, I mean, this just shows our versatility. Which of the following, I guess, protocols and languages do you use to access your data? Far and away, we have Java. Okay, Java, SQL, MapReduce. That would be for our Hadoop acceleration, and then the list goes down from there. And let's see, what do you connect to? It's interesting when asking, because this is the slide that really changes from vertical to vertical. So it's just interesting to see that in the software developer / mobile app developer, Mongo and HDFS are this high. Like if we were in financial services, it would be Oracle and Postgres at the top. So this is kind of a neat difference that we see between verticals. I think another thing that's important here is that we've got a NoSQL solution at the top. And then followed below that, we get into our relational databases too. Okay, so we then asked, how important are each of the following product features to your organization? And what leads here is Data Grid, which is where we have our distributed data cache. Compute Grid is a parallel processing engine. The in-memory file system. Service Grid. Another thing that we can do is we can help build or extend a microservices architecture into our in-memory grid. ANSI SQL 99 compliance, that's processed in our SQL Grid, another key feature. Streaming Grid, support for containers, and Spark, Hadoop, and it goes down from there. Okay, so getting to the meat of things. Our first case study that I have is a company called Intelligent Pipe. They're a big data software company. They serve the global telecommunications industry. Essentially, Intelligent Pipe monitors devices and monitors networks for telcos. And this is important because they're collecting and analyzing huge amounts of mobile user traffic data and mobile user behavior data. And they're doing it in real time because then they provide insight to the network operators for how, how to launch new products, how to optimize their networks, things like that. And so we're talking about a company that is actually constantly running real-time analytics on tens of millions or more user sessions, which is pretty intense. And so they use GridGain Professional Edition to build a high performance and low latency analysis platform where they have data feeding in from different carriers and from different user devices, like to into their cloud, where they then run real-time analytics on it, which it's multiple terabytes of data, like analyzed in Windows throughout the day. And I always love these quotes, something like, GridGain ensures responsiveness regardless of how much information we need to search through. And that's because we're doing things in memory instead of reading them off disk. So they use this real-time analytics to provide timely insight into what the different devices that they're monitoring are doing. They also were able to integrate the system that they built in GridGain using our unified API and our SQL 99 support. They were able to integrate their new environment so that they could continue to use their analytics tools that they had been using before. And then what they have found over time is that as their business grows, and remember, we're talking about tens of millions of users, they're seeing linear scaling across their deployed servers, as well as the ability to add additional servers to the cluster to grow it. And sort of here we get to a bottom line statement of we want to use the GridGain technology so that we can focus on our core business ourselves. And I think that's the one of the essences that I talk about again and again as I talk about in-memory computing is in-memory computing solves a lot of infrastructure problems, specifically those around performance and scalability. And this now frees you so that you can focus on solving the more interesting problems that are core to your business. Another use case we have is the ability to process high-speed transactions. So the way I look at it is this: you've got when you have your mobile app or even a web page, and that's running on a user's device. Okay, the user sees one thing, right? They don't understand what's going on in the background. They see one page, right? It's a product page. There's a product on it. That's all they see. They don't see that that one page is actually assembled from hitting, 3, 4, a dozen, 20, whatever, however many back-end systems it has to hit in order to get the various components for that product, like the images, the reviews, the specs, inventory information, all that stuff, right? And so each one of those elements has its own performance characteristics, or actually retrieving and serving each one of those elements has its own performance characteristics. And so when a user sees one page or entity in an app, that's really something that is quite challenging on the infrastructure. And a user will give that, I mean, what, 2 seconds, 3 seconds, maybe 5 seconds at most to load, or else it's too slow and he's moving on. So if you think about, now you have 3 seconds to load an entire page, then now you're talking about milliseconds to load each entity. Okay, so, and especially when it comes to the transaction, because once you've moved something into your cart and you're buying it, like, that is absolutely not the time for a solution to slow down. So basically, moving your data into memory will get you 1000x performance gain right off the bat, simply because memory is faster than disk. And then adding the ability to do distributed parallel processing compute, as well as the distributed data cached in memory, give you additional speed gains. GridGain and Apache Ignite have ACID compliant transactions, which is a huge differentiator for us as an in-memory technology. And we also have ANSI SQL 99 compatibility for interoperability to all the other systems that you're running, like inventory management, shipping, and analytics. So we'll do real-time analytics, like fraud detection. And all this has to happen very quickly. So this is a great example of the power of in-memory computing. Okay, looking now at another customer, Cyberdust. This is kind of a cool thing. It's a Mark Cuban funded company. It's a platform for text messages. The goal is to create a safer place to text. These are like disappearing, untraceable, encrypted messages. The app also includes prevention for taking screenshots. And this is an app that's available on Android and iOS. And now if you think about the challenge of this, right, now you have to build real-time, reliable, high availability server infrastructure, because now it's a messaging platform, right? And this is the kind of thing that will get adopted very quickly and scale very, very quickly. So you've got some real performance challenges here. They currently have over 500,000 users, and they're processing millions of messages in a day. And now here's actually a benefit of doing all of this in memory, which is that if you're developing a system where the messages disappear, then what better way to do that than to never write it to disk to begin with? So CyberDust used GridGain Professional Edition to build their messaging platform. They built it on Amazon EC2, and they hold all user account data, configurations, and messages in memory. Messages are deleted without a trace because they were never saved to disk in the first place. And they make extensive use of our unified API to connect to other systems for performance monitoring, as well as for like billing and analytics. So, okay. Now, another thing that's very cool about CyberDust is that they have this blast feature where essentially you can say, okay, send this message to everyone that I know who's using CyberDust. And so they've actually used this this feature. It's funny. The example they give is Mark Cuban sending a message to everyone he knows saying that they're giving away free T-shirts at the basketball game, and so they've benchmarked this as achieving 300,000 messages were sent and then disappeared. Hey, any webinar that gives me the opportunity to use the word disappear in this way, it's like I'm talking about Argentine politics or something. The real world performance, the messages were sent and they disappeared in 30 seconds, which is kind of amazing if you think about just generating and then removing 300,000 things in 30 seconds. We've got these quotes from the CTO of CyberDust about how much they love GridGain and how much GridGain has to offer. So, I mean, that's one of the things that we talk about a lot is that there are other in-memory point solutions. We're an in-memory computing platform. There are more capabilities than could go into all of the webinars in a year to really talk about. And what are these capabilities, you might ask? So I showed this slide before. Basically, we split our feature set out into what we call grids: data grid, a compute grid, there's a SQL grid, streaming data analysis, the service grid that we have that ties it all together. And we also do Hadoop acceleration as well. And we do this with advanced clustering. This can be where nodes find each other, clusters find each other, nodes can fail over to each other, clusters can fail over to each other. And I mean, I already went through this. So let's see. Our in-memory data grid is sort of the core element of all of this. And this data grid is what I was talking about, gets inserted between an application and a data layer, and you then move your disk-based data into memory, and at the same time, you can continue writing to your database so that that can continue to be your system of record. We're an in-memory key value store, and we basically give you great, in-memory performance and scalability, the ability to run ACID-compliant transactions in memory is a key differentiator for us. And let's see, distributed SQL queries with distributed joins. There aren't that many other in-memory solutions that speak SQL. Basically, this goes through how we work with a relational database. We've got read through and write through functionality because remember, in some ways we're a cache. And then, so write through is for immediate consistency, and right behind would be for eventual consistency, like when performance is more important than consistency. And you can configure the cache to do all kinds of different things. But one thing that I think is really cool is that we now have a database schema mapping wizard. So you get a web interface, you point this web interface at your ODBC connection to your existing backend relational database, log in, and it starts to import all of your schemas and recreate them in our data grid in memory, which makes this an awful lot easier than what you would expect. Key to the whole thing really is our SQL grid, and this allows you to access the data that's residing in the data grid using SQL commands. Like, well, we know what SQL commands are: select, update, insert, stuff like that. It also gives you a distributed SQL. So especially this is important looking at the ability to do distributed joins. So you can actually like run the SQL in a distributed fashion where the data is, and then you're only going to provide the data that's like at the end of the operation back to your application. Like, so not every element of the join. And so you achieve greater speed this way. It's basically like pushing the code to the data instead of pulling the data to the code. We also have geospatial support that's built into the SQL grid for those of you that are building location-aware applications. Our compute grid is another cool thing, right? This is a parallel processing of CPU-intensive tasks, building dynamic clusters. You can establish a bunch of load rules and then will enforce them automatically. And you can also schedule jobs, and you can build a variety of checks on those jobs to make sure that they're running. And we use a pluggable SPI design, so you can move your compute, you can move your code around to where it's most needed. The service grid ties it all together. And basically, this is an element that runs on each node so that all of the nodes throughout a cluster communicate, and they know what's going on in case that there's a load balancing or a fault tolerance situation. And you have a whole variety of options where you can like pin data or compute onto a single node, or you can allow the system to just deploy it automatically. In which case, service grid is like how GridGain or Ignite knows where different elements of your environment actually live. Okay. We also do in-memory streaming and complex event processing. This is actually another cool thing that we do that not every other in-memory solution does. And basically, you've got streaming data. There's no beginning, there's no end. You can't wait until you collect it all in order to start analyzing it. So how do you work with it? You build these windows, and you start to communicate with each you build these windows, and then you analyze the data within each window, and there's your timing. And also with the complex event processing, you can build an entire workflow, and then you can analyze the data that your application needs in real time. Okay, and I'm on my last slide, everyone. This is the in-memory Hadoop acceleration. So, you know, part of the big data world is having an awful lot of data, and a lot of people use Hadoop and Spark for big data. And essentially, we have an extent. We can provide an extension to move your disk-based Hadoop data, either move it entirely into memory or simply use our in-memory MapReduce for performance gains as well. And you'll get read-through and write-through to your Hadoop installation. Okay, and now I'm going to open the floor up to questions. Elisa, do we have any questions?
Hello. Well, the first question is for me, and that is, will the audience get a copy of your slides and the recording? And the answer is yes. After the event's over, I'll go ahead and process everything and send everyone a link to both the recording and the slides. So if you have any questions for Matt, go ahead and enter them in the questions field in the GoToWebinar control panel. We'll give people a couple of seconds. Okay. Hey, Matt, I don't think we have any questions. You must have done a really great and thorough job.
Oh, okay. Okay, well, so anyway, my email address is matt.sorrell@gridgain.com.